Okay, now the, let's say, academic 2 minutes has passed, so I think we're going to start the conference and the webinar. And first off, greetings to everybody and welcome to my first webinar presentation at CSC. I'm Jukka Nousiainen, working as a systems specialist in the CSC Computing Environments group, and today I will be giving you a short presentation on the cPouta cloud service of CSC. And the premise is, let's say, beginner oriented. So anybody who potentially has not used OpenStack or cPouta before, or anybody who has general interest on the subject of running virtual machine instances in the OpenStack cloud should be a good audience for this particular webinar presentation. First, a little bit about the pragmatics. In familiar setting, I will do the presentation first, and then let's have questions after that. If anybody has any Q&A, I can also enable the microphone controls if anybody wants to have a voiced opinion rather than use the chat box. So a little bit about cPouta, for which I have the login screen here on screen shared. cPouta is the main production infrastructure as a service cloud at CSC. It has been in pilot use since 2013, after which it went to production. So we are in the second year of production use and having steady growth on this platform. Its mainly intention is to provide a platform for research and educational purposes, let's say from HPC to various other types of scientific computing and modeling types of activities, but by no means restricting to just those kinds of use cases. cPouta is based on the OpenStack platform, which is a free open platform for cloud computing use created by various parties in the ICT industry, from NASA to Cisco and whatnot. And today we're going to focus solely on the graphical user interface component of OpenStack or the cPouta solution. So OpenStack all in all has a graphical user interface, a CLI or command line interface, and a very flexible and powerful programming API. But the premise of this particular webinar today is solely the graphical user interface. A little bit about who can get access to cPouta. Since cPouta is intended for academic use, anyone who belongs to an organization that is member of the Haka Federation in Finland can essentially get credentials for accessing cPouta. And in this case, the sign-up is done via the so-called scientific user interface at the address sui.csc.fi. It's also possible to use cPouta for commercial or for non-public academic use whose results are not published, in which case there is a separate application form for computing services that is filled. And then alongside that form you also fill out details about the project for which you apply for with these resources and so on, who gets the credentials. But that's that for the introduction part. So without further ado, I'll go forward with the hands-on part of today's webinar. So the intention is essentially to create a virtual machine instance into the cPouta cloud to see that we can get it up and running up to a point where it could be used, for example, to install scientific computing software or any other software that would assist research. So I'm going to log in now. I have a ready-made credential, and if you're a researcher at the university, you can apply for these credentials at the aforementioned places. And then I'm going to go into a project dedicated for our computing environments, and then we can take a view on quick glance of the OpenStack user interface. So you see here certain components of the UI. We have overview, instances, volumes, images, access and security. In overview, it's just that, so we see how many, for example, floating IPs are still available and what's the situation in terms of core usage and memory usage and so on. So good for a good checkup. Good for a quick checkup of how things are going in my particular computing project, and do I need to, for example, apply for additional resources. Under Instances tab, the configuration and management of the VMs themselves is done, and for any persistent disk space, the management of the persistent volumes is done under the Volumes menu. Images contain pre-built images that are constantly being generated with the latest security upgrades and whatnot. So here you see that currently out of the box we support in this particular project the Ubuntu and Scientific Linux and CentOS and 7 and 6 flavors. And the access and security portion of the UI is just for that, what it says, generating access control lists, key pairs, and firewall rules. So, how I'm going to start preparing for my instance is as follows. I have a prerequisite list, which essentially has two items. I first need to generate an SSH key pair, and then I need to check the IP address for which I'm going to log in from to the cPouta cloud instance. So the source IP of the machine I'm logging in from. The first part is easily arrangeable. So we go to Access and Security and Key Pairs, and we can create a key pair in the cPouta user interface. Of course, you can also import a key pair that you have generated yourself with an OpenSSH key generator and so on and so forth. But in this case, for illustrative purposes, let's create a key pair called Webinar Test. I'm going to download the private key for this particular key pair, and let's see that we have it downloaded there. And then as a next step, I'm going to upload it to a server that I will be using for accessing the instance that I will create. So in this case, the server is called Delhi, and I will in the following upload this said key. So webinartest.pem is going to be uploaded here. Just came to my mind that it might be a good idea to increase the font size for the webinar recording a little bit further, let's say to 18. There we go. So now I have the key. It's not in perfect condition out of the box as it is downloaded from OpenStack because it's not password protected by default. So what I'm going to do is issue SSH keygen command for this particular key to password protect it further, just so that no malicious party would have easy access to this particular key and the hosts that is connected to. But first I need to modify the permissions. So let's do chmod 0600 webinar test.pem and then SSH keygen. And now it's not protected by the password yet. We need to have a stronger password. There we go. And what I'm going to do is then move this particular key into my .ssh directory, which is the most natural place for storing those. So that's part one of the prerequisite list. Part two was the access control. So as we take a look at the instances that we have running here, they have the option of defining these security groups that essentially define the source IPs that have access via a particular TCP port or other type of IP-driven service to this instance. So we need to define at least the source IP for our SSH origin for this purpose. So how I'm going to do that is curling service such as, let's do ident.me, and they provide the one-side IP address that you are interfacing this site with. Of course, I could do the same thing in the web browser if I would be running this on a Linux workstation directly. But in this case, I'm using a jump host. So here we get the SSH source IP, and now we are able to go to the cPouta user interface, access security portion of the UI, and create a security group. So in this case, I'm going to call it SSH. So SSH access from Delhi server. Let's create it. And then manage the rules so we can add the source IP to this particular security group. So I'm going to add this as a /32 host specific subnet and define the SSH port 22 for this security group. And that's it. The prerequisites for creating the instance, the key pair and the bare minimum security group are now done. So we can now proceed to the instances page and start the instance creation itself. And this is, I would say, rather simple. So UI-driven, we start the process from the launch instance button here. And at the beginning, we are presented with the choice of availability zone. This is kind of a logical grouping which allows, let's say, physical isolation between distinct power sources or distinct network equipment. In this case, we have a single availability zone, Nova. So we're just going to use that. Different OpenStack installations could have different availability zones. And we're going to give the instance a meaningful name. So let's use Jukka Nousiainen webinar test. If I use the word test, this implies that most likely this instance is a throwaway one and can be discarded later on. There are different set of flavors that define the resources that are allocated for the virtual machine instance. So the default offered is tiny, which has only one virtual CPU, a modest amount of root disk and ephemeral disk and memory available. Something that would be suitable for running, let's say, a database application would most likely be a small flavor, since it has 16 gigabytes of RAM. Then if you require lots of cores, you most likely would go for a large flavor. And then there is also a full node flavor available, which most likely requires a separate resource request, because that then captures the whole hardware where the compute node of this particular request resides. For the purposes of this demonstration, let's go for a small flavor. So 4 virtual CPUs, 10 gig root disk, 220 gigabytes of ephemeral disk, and 1 instance count, so we don't generate copies of this VM. I'm going to boot from a ready-made image, so we'll use, let's say, CentOS 7 for this particular instance, and that's that for the technical portion of the instance configuration. And as you see, there's a lot of resources still available for this project, so we're not exhausting our quota by this demonstration, by no means. For the access and security, I need to select my webinar test key pair and then my SSH Delhi security group so that at the bare minimum I have at least the SSH connection firewall hole punched into the firewall for access remotely. There's some other options too, which we're not going to configure at this time, so I'm simply going to launch the instance after this point. And we see that the block device starts to get created, after which the spawning of the instance happens. So it should take a little while, and then the instance has been booted. And if we now look at the actions, what we could do for this newly created instance, the first one is associate a floating IP. So all of the instances in an OpenStack installation are in a local area network type or a private network by default. So they need to be given a so-called floating IP, so they would have access from the public internet. And this is just what we're going to do. So we're going to associate a floating IP so that we would have access to this LAN side IP address from our Delhi server. And it happens so that there's two IP addresses available. So I'm going to select this 71 here and associate this with the host, like so. So now the IP address has been allocated, and we should be able to access this host very shortly. But first I'm going to do a little bit of observation about what has happened after the instance has started. So we should have in the instance specific menu where I got by clicking the instance name, the log for this particular instance. So here we actually see that we have successfully injected an SSH key based on the key pair that I just created into this host. And that gives me further proof that I should be able to access this instance. And in the log tail, we actually see that the very familiar Linux login screen is already presented here. There is also the option to access the virtual machine console via the UI, but our intention here is, of course, to access it remotely. So what I'm going to do next is copy the public IP address from here to my SSH client. Having done that though, I just remembered that I do not have an SSH agent running yet. So I'm gonna do like a one-off type of startup for the SSH agent. If you are running a desktop-based Linux distribution, this is done for you when the window manager starts typically. So this is a one-off type of thing. And after that, I will add the key that I have recently created. So ssh add.ssh/webinartest.pem. And it should ask for the password that I used. So we put webinar test pem into our keychain, as it's called. And then we should have a ready-made identity for accessing our new instance. And of course, using this password to protect the private key is highly recommended, which is why I also wanted to show it in this particular webinar demonstration. After that, we're going to do ssh-l cloud user, which is the default username for the CSC built images, and use this public IP address and see what happens. It seems that we have actually successfully opened the firewall with our security group, so the initial SSH handshake is working already. So we surely want to continue connecting, and we have just logged in to the OpenStack, our VM instance that we have generated in our cPouta IaaS. Okay, but let's do a little bit of additional verification still. So we could, for example, grep for processor from /proc CPU info. We see that we have the 4 cores here available that I defined in the flavor. We see, well, this is a bit uglier. Let's put it like this. We see that we have the 16 or so gigabytes of memory available for the operating system. And then for the mounts as well, we see that the root file system is 10 gigabytes, and there is the 220 gigabyte ephemeral disk available here as well. So now we could do, let's say, installation of our favorite scientific software, or install something from Yum, Git, whatever is your defined software source. Or it is of course possible also to roll your own OpenStack images. So potentially software that you would like to be included by default as the system start can be also baked into the image itself. But in this case, I'll do a simple sudo yum update to just see that we get the latest packages for this CentOS installation. And this now gives us a starting point. We now have a first instance in our project that we have created for any type of scientific computation, HPC, data modeling, and so on. So more of these instances could be spawned via the graphical user interface, via CLI tools, or via the very flexible Python API, which of course is the fastest way to create let's say clusters of multiple tens of machines, if you will. And that actually also concludes my presentation for today.